This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 3.6, Polynomial Inequalities and Rational Equations. I think this lesson will probably take us 2 days, so it will be broken up in half for you. Okay, so what you should be able to do by the end of this lesson is you should be able to solve polynomial inequalities, and you should be able to solve rational inequalities as well. So polynomial inequality is just as a quadratic equation can be written in the form ax squared plus bx plus c equals 0. A quadratic inequality can be written as ax squared plus bx plus c, and then in this space right here would be one of our inequality signs. When the inequality symbol in a polynomial inequality is replaced with an equal sign, a related equation is formed. Okay? So here's our first one that we want to give a shot. So we've got a quadratic inequality. What we're going to start by doing is actually changing this so that it's an equation. Okay, so I'm going to open up another space to work. And again, our inequality is x squared minus 4x minus 5 is greater than 0. And again, our first step is to take it and change it to an equation. Okay? So what essentially we want to do is we want to find all of the zeros of the function. So we find the zeros by factoring. We know it's x and it's going to be plus minus. Two numbers that multiply to be a negative 5 and add to be a negative 4 is plus 1 minus 5. So we get our zeros to be negative 1, 0 and 5, 0. Okay? So those are our x-intercepts. So what this is going to allow us to do is actually take a peek at this function based on its values. So the way we wind up looking at this is through creating a number line and taking those values that I found for my real zeros and placing them onto the number line. Okay? What we're going to do is we're going to look at all of my open intervals and decide whether my function, what kind of values my function gives us, either positive or negative. And the way we do that is by finding test values. Okay? So for example, if I want to do a test value somewhere in this interval, we're going to pick a number that's less than negative 1. So let's say we choose negative 2. Okay, so on the interval from negative infinity to negative 1, let's say I choose negative 2. So we're going to test that value. What we're going to do is we're going to plug it back into my original, and we're going to see what we get. Okay? Negative 2 squared is 4. Negative 4 times a negative 2 is a positive 8. Minus 5 is going to give us a value of 7. So I know that this is positive. And what that means is if the function's value is positive, it lies above the x-axis on this interval. So my next one, we want to choose a value between negative 1 and 5. The easiest test value, of course, is going to be 0. And that gives us, very quickly, we know when we plug 0 in, we get negative 5. So that gives us a negative value, which means it's going to lie below the x-axis. And again, between 5 and infinity, choose a value, let's say 7, and that's going to give us 49 minus 28 minus 5, which is 16. So there's a positive. Okay. So since we're solving x squared minus 4x minus 5 is greater than 0, the solution set consists of only 2 of the 3 intervals. Okay? Only 2 of these 3 intervals make sense. We want it to be greater than 0, which means it has to be positive. So what actually winds up being our solution are these intervals where the function is positive. It's greater than 0. Okay? So my solution winds up being from negative infinity to negative 1, union 5 to infinity. And that's using interval notation. The other way we could write it would be x such that x is less than negative 1 or x is greater than 5. Okay? So again, what we did is we made our inequality an equation. We solved for the zeros. We placed those values of x on our number line, and we determined where the function was positive and negative on each interval. And then we looked back at our inequality and decided what fit. Greater than 0 would mean positive, less than 0 would be negative. Okay? So here's our solution. Okay. Let's take a look at another one. X squared plus 3x minus 5 minus x minus 3 is less than or equal to x plus 3. Did I type in the other one incorrectly? I did. I'm sorry. We're not going to use this one. I, for some reason, have this minus x and I shouldn't. Minus x. And I shouldn't have this minus 3 either. I got ahead of myself and started to do the problem without thinking. Sorry about that. So we're going to use this one here. X squared plus 3x minus 5 is less than or equal to x plus 3. So as most of you already are thinking, we want to get this so that it's less than or equal to 0. So we want to get everything to one side, which is pretty easy to do. We're going to subtract that x, and we're going to subtract the 3. And what we wind up with is the resulting inequality. X squared plus 2x minus 8 is less than or equal to 0. Okay, so from here we follow that same procedure. We start by finding the zeros. We do that by factoring. Okay. What two numbers multiply to be 8 and subtract negative 8 and subtract to be 2? That's going to be plus 4 minus 2. So we get the values of x equals negative 4 and x equals 2. And these are my zeros. So my next step is to take those values and set up a number line. Negative 4 and 2. And now we're going to go through and we're going to see where the function is positive and negative by doing test values. So let's try a value of negative 5. Okay. So we could go right from here if it's easier. Negative 5 squared is 25. Negative 5 times 2 is a negative 10. Minus 8 gives us a value of 7. So that means the function is going to be positive here. Between negative 4 and 2, f of 0, of course, is going to be our easiest, and that's very quick to calculate. Negative 8. And then larger than 2, let's try 4. 4 squared is 16, plus 2 times 4, which is 8, minus 8 gives us a value of 16. So that's positive. Okay. So if the function has to be less than or equal to 0, and now here's something important. Now we're getting into equals, right? So we have to take that into consideration. Where is it less than or equal to 0? That means where is it going to be negative? Okay, here's where my function is negative. Here's where it's equal to 0. So that needs to be included in my solution. So my solution is going to be negative 4 to 2, including those values because that's where it's equal to 0. Or negative 4 is less than x is less than or equal to x is less than or equal to. And there's your solutions. Okay, so let's get into something that looks a little bit different. Let's talk about a cubic. So x cubed minus x is greater than 0. So first step, just like the last one, we set it equal to 0. And then we begin to find my zeros. So we're going to pull out a GCF, continue to factor. We get x equals 0, x equals 1, x equals negative 1. So now we actually have 3 values that we're going to have to place onto that number line and decide what to do with. Okay. So that's exactly what we're going to do. We're going to start our number line. We've got negative 1, 0, and 1. Then we go to our test points. So let's say between negative infinity and negative 1, we choose negative 2. So when I plug negative 2 in, I get negative 8 plus 2, which is negative 6. Between negative 1 and 0, let's say negative 0.5. And you can use your calculator for that if you'd like. Okay. X store negative 0.5. We have x cubed, whoops, minus x, 0.375. Okay, so far I have a negative and a positive. Between 0 and 1, let's try a positive 0.5. X store 0.5. Go up and borrow this. And we get 100 and, oops, this is supposed to be 0.5, isn't it? Negative 0.375. So there I'm negative. And then above 1, so let's try f of 2. 2 cubed is 8, minus 2 is 6. We're positive. Okay, so again, we want where we're greater than 0, so where our function is positive. So my solutions are going to be from negative 1 to 0, and then 1 to infinity. And notice I'm using the open brackets. I'm not including those values because that's where it's equal to 0. The other way we can write this, x such that we are between negative 1 and 0, or x is greater than 1. Okay, so the steps in solving a polynomial equation inequality, I'm sorry, is first to find an equivalent inequality with p of x on one side and 0 on the other. So get it so that everything's on one side, so that it's greater than or less than or greater than or equal to 0. Okay. Change the inequality symbol to an equal sign and solve the related equation. Use the solutions to divide the axis into intervals, then select a test value from each interval and determine the sign of the polynomial on the interval. Determine the intervals for which the inequality is satisfied and write interval notation or set builder notation for the solution sets. Include the endpoints of the intervals in the solution set if the inequality symbol is greater than or equal to or less than or equal to. Okay, so I don't want to get into, well, let's try one more of these, I suppose. Okay, I'm not going to get into the rational inequalities, but we will do one more of these and then we'll save the rest for the next time around. Okay, so we're going to try this one here. Okay, so again, we're going to start by getting everything to one side so that we have a 0 on the right-hand side of this polynomial. So 3x to the 4th minus 11x cubed plus 10x minus 4 is less than or equal to 0. And then what we're going to do is we're going to make this into an equation. So now what we have to do is we actually have to go and use how we were able to solve these upper level or higher degree polynomials in the last few sections. And we need to figure out what my solutions are here. So we have to use all those theorems and all that other great stuff that we learned in order to do that. Okay, so here's what we're going to do. We're going to start by doing our P over Q. We're going to determine all my possible rational zeros. So my P over Q, we're going to have my possible factors of -4, which is going to be plus and minus 1, plus and minus 2, and plus and minus 4. My possible factors are 3, 1, and 3. All right. So then what we need to do is we need to take a peek at the graph and decide what's plausible. My possibilities being plus and minus 1, plus and minus 1/3, plus and minus 2, plus and minus 2/3, plus and minus 4, plus and minus 4/3. So we need to decide what I think is plausible. So we're going to go and we're going to graph it. And we're going to graph it as an equation. X to the 4th minus 11x cubed plus 10x minus 4. So here's our function. So our possible zeros, right? Let's get this out of the way. It's hard to see. So maybe -1. That looks pretty spot on. Maybe a half, and then maybe 1, 2, 3, 4.5. So -1.5 we're going to start with. Okay, and if we look, -1, here is this one, and a positive 1/2. Do I have a positive 1/2? You don't have a positive 1/2 as part of this, but I do have a positive 2/3, and that might be close. Okay, so we're going to start by checking that. And the way I would like to do it is by using that synthetic division, because I found that that was pretty easy to use. So if we're starting with that -1, what we're going to be dividing in, we're going to have my -1, and then, oops, I need to see this. We've got 3, -11, 0 for our x squared, 10, and -4. Drop that 3. -1 times 3 is -3. Add those together, -14. -1 times -14 is 14. Add 14. negative 14, negative 4, 4, and 0. So since this is 0, it is a factor. So I know one of my factors is going to be that x minus 1. So I know negative 1 is going to be a solution, so it's got to be x plus 1, right? And then we have constant x squared, x cubed. So here's that second piece of my function. Okay, so the next thing we're going to do is we're going to test that second value that we weren't really sure of, maybe that 2/3. And remember, we can do it with a fractional value. There is another way we can test it, and that would be to use the remainder theorem. But the nice thing about synthetic division is it gives us that other factor. So let's try 2/3. And let's use this piece here, 3, negative 14, 14, and negative 4. Drop that 3. 2/3 times 3 is 2, which brings us negative 12. 2/3 times negative 12. Gives us negative 8. 14 minus 8 gives us 6. 6 times 2/3 gives us 4. Negative 4, and that gives us 0. So look at that. We have another factor. So now we have x plus 1, we have x minus 2/3, and we have 3x squared minus 12x plus 6. Okay? So we've got some pretty good information here. I never stopped from, we're going over on my time, aren't we? Okay, so we've got some pretty good information here, but we're going to have to deal with this piece here. Okay? What I'm going to have to do with that is I'm actually going to have to use quadratic formula in order to solve that out. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 12 squared is 144 minus 4 times 3 times 6, which is 72. You know, 72 can be divided into 36 and 2. So 6 radical 2. So this gives us 2 plus and minus radical 2. Okay. And so now we have all of our solutions. Okay. We have x equals negative 1, 2/3, 2 plus radical 2, and 2 minus radical 2. And we know that's all of them because if we looked, we have a degree of the polynomial being 4, and we have 4 solutions. Okay. I am way over on my time here. I really apologize, guys. So what we're going to do is we're going to pick up here. You can stop watching. I am going to continue. If you want to finish it up, that's great. If not, we can finish it up in class tomorrow. But I am going to finish it on here just in case you guys do want to just finish it up now. Okay, so I've got all my pieces that I need. What I'm going to do now is I'm going to go and I'm going to place them on that number line. Okay, so here's all my values. My first one is going to be that value of negative 1. Okay, my value of negative 1, I've got that spot there. 2 minus the square root of 2 is a little less than 2/3. Okay, so 2/3 is about here. Right, that's about 2/3, and then 2 minus radical 2 is actually right here. It's right next to it. And you can find that out by finding the decimal approximation. And then 2 plus radical 2 is right about here. So now what we have to do is we actually do have to go through and kind of find those values and determine where it's positive and negative. The easiest way to do that would just be to store and put in some values here. So if I were to put in f of -2, we would get 112. So I know that here we're positive. At f of 0, I wind up with -4. So I know I'm here. Okay, because remember, I'm in between my red interval here. Let's try f of 1, which is going to give us a -2. Okay, so I'm positive, negative, negative. And then 4, I'm actually at 100. So that's positive here. Okay, so here's where my separations for my intervals were. Okay, positive, negative, negative, positive. Because what this function actually looks like, if I were to take a peek at the graph, actually looks something like this. Okay, so it comes up and touches and then comes back down. So we're positive, negative, negative, positive. Okay, positive, negative, negative, positive. Okay. So the question was, where is it less than or equal to 0? Or less than or equal to 0 is where we're going to find it being negative. So my solution, oops. Is going to be on the interval from -1 to 2 minus radical 2 union 2/3, because we know that's a 0, so we have to kind of take that out, 2 plus radical 2, and then that's going to be included. Okay. I'm sorry, I don't know why I made that rounded. That's supposed to be square. That is a 0. We want it. Okay. So there's my solution. All right, guys, I am so sorry. I went way over. I apologize. I will see you in class tomorrow. If you have any questions, please write them down. You can tweet them to me at Audrey Cucci, and I'll answer them for you there as well. All right, bye.